Now, the base resistance, if you look at the base resistance, so base resistance QB is equal to Q0 NQ AB, which is equal to QB into AB. So, Q0 it increases with a limited depth, it increases limited depth, beyond which it remains constant. For pile, up to a certain depth Q0 increases, so beyond which it remains constant. So, it has nothing to do with your embedment depth of the pile. So, that is called your critical depth, that is called your critical depth. So, bearing capacity factor at base, particularly NQ it depends upon your value of your phi. For this there are many theories has been given. First one is your Terzaghi, second one is your basic, third one is your Bridge-Hassan, fourth one is your Skempton. So, one author, that is your Berjan, Berejan, Seif et al. 1961, he gave, based on your field data, what he has given. He has given the value of NQ and this is your phi 20 degree, then this is your 25 degree, 30 degree, 35 degree, 40 degree, 45 degree. Here it is 50, 100, here it is a 50, 100, 150, 200. So, this value they have given for different L by D's ratios. First one is your L by D is equal to 5, second is your L by D is equal to 20, third is your L by D is equal to 70. You can utilize the theory of Terzaghi, you can utilize the theory of basic, you can also utilize theory of Bridge-Hassan, also Skempton. However, Berejan-Beck et al. 1961, they have given the values of NQ based on the field data of the phi for L by D 5, 20 and 70 different values. These charts you can collect it in a book, then this can be utilized to find it out your base resistance. Come to your frictional load. Frictional load, if you look at the frictional load, in frictional load QF is equal to Q0 Ks tan delta into surface area. So, Brahms has given the values Brahms has given the values for different pile materials. This is my pile material, the delta is your friction between pile material and soil, and values of ES, it is your lower dr, then this is your higher dr, then this is your steel, then concrete, last one is your wood. Delta general steel is your 20 degree, concrete it is your 3/4 phi, wood is your 2/3 phi. Then for lower dr, value of your, sorry, it is not ES, values of your KS. The KS value is lateral earth pressure coefficient, and Brahms has given the value of the KS. Lower dr means it is a loose conditions or medium dense condition, higher dr means that is your dense conditions. So, this will be 0.5 and this will be 1.0, then this will be 1.5 and this will be 1.0, 2.0 and this will be 4.0. So, dr you can calculate, dr relative density you can calculate E max minus E by E max minus E minimum, which is equal to gamma d minimum by gamma d into gamma d minus gamma d minimum by gamma d maximum minus gamma d minimum. So, from here you can find it out based on your in situ void ratio. If you know E maximum and E minimum, I am removing this one, this will be better for knowing. If you know E maximum and E minimum, and if you know what is the in situ void ratio E, then you can very easily find it out whether it is this relative density is very low or medium or dense. For low and medium, lower dr, these values has been given. For higher dr, these are the values has been given. Now, we will solve one example. Example 1, this is the case has been given. Look at here. Let me draw the pile. Pile is here. Then this is, there is water table is here. Then here it is 1.5 meter. This is your QF, this is your QB, this is your Q. So, gamma is given 17.5 kilonewton per meter cube, phi is equal to 30 degree, Ks is equal to 1.5, delta is equal to 0.75 phi. So, question is calculate ultimate bearing capacity of pile, bearing capacity of pile, right, considering factor of safety is equal to 2.5 and water table is at ground surface. So, let us start. Ultimate bearing capacity Qu is equal to Qb plus Qf. So, which is equal to Q0 AB NQ plus Q bar AS Ks bar tan delta. So, Q0 is equal to gamma L, which is equal to 17.5 into 1, sorry, it is not 1.5, rather it is 15 meter. into 15, which comes out to be 262.5 kilonewton per meter square, and Q bar is equal to half gamma prime L, which is equal to 131.75 kilonewton per meter square. A B is equal to pi by 4 into d square, base is your d square. So, diameter is given, diameter is, this diameter is your 45 centimeter. So, this will be, comes out to be 0.159 meter square. AS is equal to pi d into L, which comes out to be 21.195 meter square. Then delta is equal to, delta is 0.755, from there you can calculate 22 degree 0.5. So, tan delta is equal to 0.414. So, NQ is coming out to be 16.5. So, water table, if I do not consider the water table, without the water table, then this is my QU. QU is equal to QB into QF, which is equal to Q0 AB into NQ, and Q bar AS KS bar into tan delta. Q0 is equal to gamma bar L, Q bar is equal to half gamma bar L, AB is equal to pi by 4 d square, that is area of your base, AS is your pi dl, delta is equal to 22.5 degree, tan delta is equal to 0.414, NQ is equal to 16.5, NQ is equal to 16.5. Based on that, the QU comes out to be 2424 kilonewton, you can calculate. Then QA is equal to 2424 by your factor of safety 2.5, which is equal to 969.6 kilonewton. So, now matter is there, if water table is at the ground surface, what will happen? Then water table is at ground surface, then gamma saturated is your, that is given, that is your 18.5 kilonewton per meter cube. So, gamma submerged you can calculate, which is your 8.69 kilonewton per meter cube. Then you calculate QU. So, QU comes out to be approximately, that is your 1200 kilonewton, and QA is equal to 480 kilonewton. Almost more than 50%, half of this value has been reduced. Ultimate bearing capacity without water table, that is your 2424 kilonewton. With water table, it comes out to be 1200 kilonewton. So, Q allowable is comes out to be 480 kilonewton. Here Q allowable is comes out to be 969.6 kilonewton. One more example, let us consider one is your layered soil, then we can calculate for layered soil how it looks like. Example 2, there is a pile here, this is your 8 meter, 6 meter, 2 meter. So, dia is your 0.45 meter, gamma D1 is your 16.5 kilonewton per meter cube, phi is equal to 30 degree, E is equal to 0.6, gamma D2 is equal to 15.5 kilonewton per meter cube, phi is equal to 35 degree, E is equal to 0.65, then gamma D3 is equal to 16.0 kilonewton per meter cube, phi is equal to 38 degree, E is equal to 0.65. So, gamma D1, gamma D2, gamma D3 is given. If I write it in the formula, gamma D is equal to gamma W G by 1 plus E, then G is equal to gamma D into 1 plus E by gamma W. So, what are the steps? The steps you have to follow: calculate G, find G. Once you find G, then find it out gamma saturated, which is equal to gamma W G plus E by 1 plus E. Then you can calculate gamma submerged, which is equal to gamma saturated minus gamma W. Then you can find it out. That is your case. Qu is equal to Q0 NQ AB plus P summation of Q0 bar Ks tan delta delta L. Then I am writing the procedures, you can try it. Q0 bar 1, that means this is layer 1, this is your layer 2, this is your layer 3, this is at the base. So, which is equal to half delta L1 gamma submerged. Q02 is equal to delta L1 gamma submerged plus half delta L2 gamma submerged 2. If I put it, this is my delta L1, this is my delta L2, this is my delta L3. Similarly, Q03, these are the average value. I'll come back, let me write it first. This is your delta L1 gamma submerged 1 plus delta L2 gamma submerged 2 plus half delta L3 gamma submerged 3. So, then perimeter you can find it out at the base. At base, considering this is my base layer, phi is equal to 38 degree, and Q is equal to 95. Area of the base you can find it out 0.159 pi by 4 into d square, this is your 0.45. Perimeter you can find it out because a cross sectional throughout is same. So, perimeter is equal to 1.4287. Then Ks you can find it out. Ks is equal to half tan square 45 degree plus phi by 2, which is equal to half Kp. Let me start with this. For each cases, let me find it out. For layer 1, gamma saturated, layer 1 G is equal to gamma D into 1 plus E by gamma W, which is equal to 2.69. Then gamma saturated is equal to 20.17 kilonewton per meter cube. Gamma submerged is equal to 10.36 kilonewton per meter cube. Similarly, layer 2 G is equal to 2.61, gamma saturated is equal to 19.38, gamma submerged is equal to 9.57. layer 3 G is equal to 2.69, gamma saturated is equal to 19.85, gamma submerged is equal to 10.05 kilonewton per meter cube, kilonewton per meter cube. Now Q0, based on that, Q0 you can calculate gamma submerged 1 delta L1, gamma submerged 2 delta L2 plus gamma submerged 3 delta L3, which is equal to 160.40. If you come back here, so example 2, there is a layer case. In the layer case, earlier I have said for layered soil Qu is equal to Q0 NQ AV plus P summation of Q0 bar Ks bar tan delta delta L. Now if you look at here, there are 3 layers, layer 1, layer 2, layer 3. What are the parameters have been given? Dry density has been given, phi has been given 30 degree, then E has been given. So what is missing? Water table is at the ground surface. That means you need to have your gamma saturated unit weight. To get gamma saturated unit weight, you have to calculate your specific gravity G. So gamma D is equal to gamma W G by 1 plus E. So from there you can calculate G. Then once you calculate the G, then you calculate gamma saturated is equal to gamma W into G plus E by 1 plus E. Then gamma submerged is equal to gamma saturated minus gamma W. Then Qu is equal to Q0 NQ AB plus P. P is your perimeter, summation of Q0 bar Ks bar tan delta delta L. Tan delta we have calculated. Every case delta is given, delta whether you can take it or you can find it out from there. So delta you can take it into take into consideration of delta between, because here nothing has been given, you can take this value, it is still delta you can take it 20 degree, or you can consider delta value is your delta is equal to, if it is not given, 2/3 phi to 3/4 phi. This value you consider. So then what are the parameters to be calculated? NQ, AB, Q0, phi is equal to 38 degree, NQ got it 95, area of base is your 0.159, perimeter is your 1.428, so Ks is equal to half Kp. So Q01, average value of Q01, if it is a summation, half delta L1 gamma submerged for layer 1, Q02 delta L1 gamma submerged 1 plus half delta L2 gamma submerged 2, Q03 delta L1 gamma submerged 1 plus delta L2 gamma submerged 2 plus half delta L3 gamma submerged 3. This is average value for layer 1. This is what your half has been taken, delta L and gamma submerged. For layer 2, layer 1 into gamma submerged, that is your case, plus particularly for layer 2 this is half, for layer 3 this is half, and this has been added. Then for each layer we calculate G, gamma saturated, gamma submerged. Then once you know it, then you can calculate Q0. Q0 is gamma submerged 1 delta L1, gamma submerged 2 delta L2, gamma submerged 3 delta L3. This value is comes out to be 160.40, that is your kilonewton. Then once you get it, find it out value of your Qu and Qa. You can check Qu comes out to be 2850 kilonewton, Qa comes out to be 1140 kilonewton. This is what up to the piles in cohesionless soil, granular soil, considering using static bearing capacity equations. Next class I will start piles driven into cohesive soils. One by one we will go it. So, I will stop it here. Thank you.